Welcome back. In this video, we are going to break down an important concept in Python called list comprehension. If you've ever found yourself writing loops just to create or modify a list, then list comprehension is just going to make things easier for you. By the end of this video, you will know what list comprehension is, how to work with list comprehensions from simple lists to more complex examples, and how list comprehension makes your code cleaner and more efficient. So before we go into examples and all that, let's first understand what list comprehension is itself. As you already know, a list is a collection of items in Python. Just like I have on my screen here, we have a list of numbers starting from 1 up to 6. So whenever we say list comprehension, we are talking about clear and concise way to create or manipulate a list. List comprehension is used to create a list from an existing list or an attribute data type. Data types like string, like tuple, like dictionary, like range. So all those data types that you can iterate over them. So instead of writing long loops, you can do everything in a single line of code. One thing to note is that list comprehension is actually peculiar to Python, and it's actually fun to work with. It doesn't exist in other programming languages. So normally, when you want to create or modify a list, we might use a for loop. Let's say you want to create a new list from the list we have here. We have a list of numbers. So let's say we want to create a new list, and the new list we have double of each number that we have in this list. So on a typical day, what you do is you write a for loop. So you are going to say for, then you can say number in numbers. Since numbers is our list here, we want to create a list of numbers that is double each of the numbers we have in this numbers list. Since we want to have double of each of them, so we can say number is representing each of these items now. So you multiply by 2, that's going to make it double. So we can assign this to, let's call it new number. Let's assign it to new number variable. Since we want to create a new list, so in each of the iteration, we are going to be appending new number to the new list we want to create. So we can come here and say, let's call it double number. Okay. So we can say initially double numbers is an empty list. So during each of the iteration, we are going to append new number to double numbers. So here we can say double numbers dot append. Append is a method that is used to add a new item to the end of a list. So you can say new number, right? So after the iteration, if we print double numbers, now you are going to see that double numbers is a list of. So at the end of the iteration, we want to print double numbers. We run this now. So you can see that double numbers is a list, and each of the items in double number is double of the items in numbers. So we have 1 here. 1 times 2 is going to be 2. We have 2 here. 2 times 2 is going to be 4. We have 3 here. Times 2 is going to be 6. We have 4 times 2 is going to be 8. This method is completely fine, but you can do the same thing in one single line using list comprehension. To do this now using list comprehension, we can comment this out. So to do this using list comprehension, we have double numbers as the name of the new list we want to create. So we want to create a new list from our list of numbers. So we are going to have we have the for keyword, number in numbers. Right, so before this we are going to have number. Okay, so this is a typical list comprehension. If we print double numbers now, okay, double numbers should be a list of each of the items in numbers. So this is going to be times 2. We run this again. So you see that double numbers is now 2, 4, 6, 8, 10, and 12, which is same as the result we obtained using for loop. So using normal for loop, we have this up to like 5 lines of code, or let's say 4, but here we use just a single line to achieve the same result as this. So you can see now that list compressions makes this code much cleaner and shorter, from all this to just only this. Now that you've seen a quick example, let's break down the structure of list compression. The general structure of list compression is like, let's comment this out and this also. So the general structure of list compression, the general structure is like this. You have your square brackets to signify that you are creating a new list, and then you have item for item in list. So this is the syntax for creating list compression, from creating a list from an existing list. But there's an important thing to note: list compression does not only work with lists. I mean, list compression is for creating a list, but it doesn't only work with lists. You can create a list from other attribute data type, either from string, from dictionary, from tuple, from range, and any other attribute data type. So rather than having this format, we can have a more comprehensive one. So we have the square bracket to denote that we want to create a new list. So we have item for item in list. But since list compression does not only work with list, it works with any other attribute data type. We can then call this attribute to be more all-encompassing. Attribute. All right. So any item in the attribute data type, and then this one, as you can see here, what we did here is we multiply 2 by the number, in which number is an item in the list. So rather than calling this item, also we can call this expression to indicate that you can perform any operation on each of the items. So this is the syntax for list compression. You have expression, that is what you want to perform on each of the item from the attribute. Then you have the item in the attribute, which can be list, which can be string, it can be dictionary, it can be range, it can be tuple, or any other attribute data type. So let's comment this out. This is the syntax for list compression. So the expression is the action you want to perform on each item. The item is the individual element from the attribute, and then the attribute is the sequence or collection you are looping through. We can have another example. Let's start with something simple. Imagine you already have a list and you want to create a new list with the same items. Let's say you just want to copy the items from one list to another. So using list compression, you can do this. So let's say we have a list of fruits. Let's say we have a list of fruits. We have apple, banana, and we have cherry. So using list compression now, we want to copy this list into another list. We can call the new list, or we can call it fruit copy, since we want to copy this list into another list. Fruit copy is going to be equal to, so we have the square bracket. Now our expression is going to be the same as the item, or we can just copy this so it will be easier for you to grasp. So this is the syntax for list compression. Our attribute now is fruit, which is the list we are looping over. Fruit, these are attribute. Items, we can leave it as item, or you can call it fruit, whatever you like. The expression now is the action we want to perform on fruit. Since we are just copying this into another list, so we are not performing any expression on this, we can just leave it as fruit. So if we print fruit copy now, you are going to see that fruit copy is a copy of the fruit list. So you see, this is fruit copy, which is same as fruit list. You can also perform other actions on your item. So let's say we want to turn each of these items now to uppercase. To turn string to uppercase in Python, you use the upper method. So this is going to turn the string to uppercase. Now let's run this again. You see what we have. So we have apple, banana, and cherry all in uppercase. So whenever you are working with list comprehension, you have the expression first. You have the for keyword. The expression is the action you want to perform on the item. You have the for keyword for looping. Then you have the item, each item in the iterable in the list. Then you have your iterable, which can be list, can be tuple, it can be any iterable data type. So just like I said that you can use list comprehension with other data type, you can also use it with range of numbers. Let's say you want to create a list of numbers from 1 to 5. You can use range to generate the numbers and then list comprehension to create the list. You can see that in another example. So let's call this numbers. We want to generate a numbers, let's say from 1 to, let's say to 5. So our expression comes first in our list comprehension syntax. The expression comes first since we are generating a number, so we can just pass the number straight. So we have the for keyword to iterate over our iterable, and then you have the item, which is going to be the number in the range. Then we have in range, since we are creating a number from 1 to 5, we have range, and then we have 1 to 6. So this is going to make range to stop at 5. Now if we run this now, okay, let's print numbers. Print numbers. We already have a variable with the name of numbers, so let's comment this out. Let's comment this out also. We run this now. See that numbers now is a list of 1, 2, 3, 4, and 5. So in this example now, range function generates numbers from 1 to 5. Number is each of the numbers from the range. Then each of those numbers is added to the list. Now let's say you want to square each of the numbers in the range. You can easily apply operation like squaring the numbers inside the list comprehension. So to square each of these numbers now in the range, what you need to do is just to square them. So we say number double multiply and then 2. You know that the double multiplication symbol represents raised to the power. So now we are raising each of the numbers from the range, we are raising them to the power of 2. So if we run this now, you are going to see that. So we have 1 raised to the power of 2 is 1, 2 raised to the power of 2 is 4, 3 to the power of 2 is 9, 4 to the power of 2 is 16, and 5 to the power of 2 is 25. Another interesting thing about list comprehension is it also allows you to add conditions to filter the iterable items you are working with. If you want to add such conditions, the syntax goes by. So we have this syntax for list comprehension. For example, if you want to now add filters to your list comprehension, this is the syntax for list comprehension. To add filter to it now, possibly you want to filter out some items from your iterable. So what you do is, after the iterable, you use the if keyword, which you will normally use for your conditional statement, and then you pass the condition that you want to use to filter your items. For example, let's say you only want to include even numbers in the list from a range of 1 to 10. So here we have a range of 1 to 5. Let's say we want to create a list from a range of 1 to 10. Let's call this even numbers. Even numbers. Okay. So our expression is going to be number, since we want to include the numbers from even numbers between 1 to 10. So we have 4. You can call this number. In range, we are dealing with range of 1 to 10. So that means our range is going to start from 1 and then it's going to stop at 11. Since 11 will not be included in the numbers generated from the range function. Now we want to include only even numbers. So after your iterable, you are going to have the if keyword, which is your conditional statement, and then you are going to pass the condition. The condition for generating even numbers is that your number must be perfectly divisible by 2. So you can say if number modulo 2 modulo 2 equals 0. So this is our condition. Now let's print our variable even numbers. So if we print this now, Okay, let's comment this out, and we can as well clear our console. Okay, let's run this again. Then we have 2, 4, 6, 8, and 10. You see, this is much shorter than using the regular for loop with if and else statements. This compression doesn't just work with numbers. It can also be used with strings, tuples, or other attribute data types. For example, let's extract each letter from a word. Let's say we want to create letters from a string. So list, you have the square brackets. We can call this letter, and you have the for keyword, then you have your item. So we can also call this letters since we want to extract letters from a word. Then you can say you can use any string. We can say Python. Okay, so now let's print letters. So letters now is going to be a list of the letter in Python. We run this, let's comment this out so it doesn't print that again. So you can see now that, so here each letter in the string Python is treated as an item in the list compression. During the first iteration, letter is going to be P, and then P is returned. In the second iteration, letter is going to be Y is returned, and then it goes on and on like that. You can perform any operation on your letter, whatever any expression you want to perform, you pass it here. For example, you can as well turn this to uppercase, so use upper method. We run this again, you are going to see now that all our letters will be capitalized. Sometimes you might work with more complex data structures like list of lists, I mean a nested list. So let's say you have a nested list like a matrix, and you want to flatten it into a single list. You can also do this using list compression. So for example, we have a matrix variable and it's holding a list of lists. So this is a list, and inside of the list we are having another set of lists. So you can say this is a list of numbers. We have 1, 2, 3. So after this we have another row. You can say this is 4, 5, and 6. After this we have another row, so this is going to be 7, 8, and 9. Now we have a matrix. So this is a typical 3 by 3 matrix. So if you want to flatten this now, you want to flatten it into a single list. We don't want it to be a list of lists. Normally using your for loop, you are going to have for the for keyword, then we can call this row. So each of the items in the matrix list is going to inherit this row, and the first one is going to be this, the second is going to be this, and the third is going to be this. So we can say for row in matrix. Now if we print row, now, I'm going to see that each of the row is going to be this list that is inside of the matrix list. Now to flatten the numbers in each of the row into a single list, we are going to have another for loop to iterate over each of this row in the matrix list. We are going to have for num to stand for each of the numbers in the row Now inside of this we can now print let's print num. Okay, let's comment this out. We already printed that. So if we print this now, if we run this, so we are going to have each of the numbers in the num rows. Now how this works is that this first iteration, this first for loop is going to iterate over each of the items of this matrix list, and the items of this matrix list is, this is the first item, this is the second item, and this is the third item. So during the first iteration, row is going to be this, this, and this. Now in the first iteration we have this to be the first row. So inside of the first iteration now we are iterating over this list again. This for loop is iterating over the matrix list, and this for loop is iterating over each of these sub lists. Now, since we want to flatten them into a new list, so we can call this, let's call it flattened list. Flattened list. So initially, flattened list is going to be empty array. So inside of this loop, we are going to be appending each of the numbers into the flattened list. So we can say flattened list dot append. So we are going to say num. So if we run this now, okay, after the iteration, we are going to print flattened list. So if we run this now, you can see that flattened list, this is our flattened list. It's a list that is created from this matrix, but we are not having a nested list structure now. We are having just a simple list. This is what is printed here. We don't need that for now. So to use list comprehension for this kind of example, rather than having this long for loop structure, we can use list comprehension. So we can comment this out. Let's see what list comprehension is going to give us. So we have the matrix here. Now we can say flattened list. Let's get rid of our console for now. So we can say flattened list is equal to, we have the square bracket to denote that we are creating a list, and then the first syntax is going to be, we have row, then the for keyword row in matrix. So, and up to this point, you understand this matrix is our iterable. Row is each of the list that is nested inside the matrix list, and then this row is going to be same as this. But if we run this now, we are still going to have the same thing as this. With this now, we are just copying the items into another list. So if we print flattened list at this point now, flattened list, if we print flattened list now, we are just going to have the same list as this matrix substructure. So you can see we have same thing as matrix because we did not perform any operation. Now we have row to be representing this. To flatten this now we want to iterate over each of these items. So after matrix, we are going to have another for loop. This for loop now is going to be iterating over each of these lists in the matrix list. So we can call this num in row. So here now we'll be returning num. We are not returning row again. So if we print flattened list now, so we have matrix to be flattened into this flattened list. So using list compression, you can see that this now is the equivalent of all this. So the first for loop we have for row in matrix is what we have here, and the second for loop is what we have here, and then we are returning num into our flattened list. At this stage, we loop through each of the row in the matrix list. Then for each of the num in the row, we add it to the flattened list. So this is much cleaner than writing multiple for loops. In this video, we learned what list compression is, how to use list compression with list, ranges, and other attribute data types like strings. We also have examples of applying operations to list items and ID conditions to filter them. List compression is a useful concept that makes your code more readable and efficient. You can keep experimenting with it and you will see how it can simplify your Python programming. Thanks for watching. Keep coding with Coding Atlas. I will see you in the next video.